What came before the beginning of time? Before the first star, before the first atom, before even the notion of space, there was only silence. Not silence as we know it, but a silence without reference. No distance to cross, no rhythm to measure. A silence unanchored by the flow of time. Science tells us of the Big Bang, the great eruption that forged everything we see. Yet even as we celebrate that beginning, a darker question emerges. How can there be a before if time itself had not yet begun? The word collapses beneath its own weight, pointing us toward a mystery more profound than any galaxy or quasar. The void that came before, if such words can even hold meaning, is not merely emptiness. It is a paradox. To say nothing existed is still to grant it existence. To say there was no time is still to frame it with time's language. Here human thought falters. Language itself becomes a cage, unable to grasp what lies beyond, and yet we are compelled to ask. Across ages, humanity has sought the first spark, the origin of all things. But in this pursuit, we find ourselves at the ultimate wall, not the birth of the universe, but the haunting riddle of what, if anything, lay beyond its birth. Perhaps nothing was never real. Perhaps the very idea of nothingness is the greatest illusion of all. In the early years of the 20th century, the universe appeared eternal and unchanging. Astronomers looked to the night sky and saw patterns of stars that seemed fixed, galaxies that seemed motionless, a cosmos that had no beginning and no end. Albert Einstein, shaping his new equations of general relativity in 1915, also assumed such a static cosmos. Yet his own mathematics rebelled. Gravity in its pure form demanded motion. Left untouched, the equations foretold either collapse or expansion. To preserve the harmony of a timeless universe, Einstein introduced what he called the cosmological constant, a mathematical correction to hold the heavens still. It was an elegant trick, but one born not of evidence, only of conviction that the universe could not have a beginning. The illusion did not last. In the 1920s, a young Belgian priest and physicist, Georges Lemaitre, dared to read Einstein's equations without compromise. If the mathematics were honest, he argued, then space itself was stretching. Galaxies must once have been closer, compressed into a single point, a primeval atom from which all existence burst. It was a vision so bold that even Einstein dismissed it. Your calculations are correct, he admitted, but your physics is abominable. Then came Edwin Hubble. From the mountaintop at Palomar, with the most powerful telescope of his time, Hubble measured the faint light of distant galaxies. In 1929, he revealed the evidence. The farther a galaxy lay, the faster it retreated. The universe was expanding. Lemaitre's vision was no longer speculation but observation. The cosmos had not always been as it is. It was born still, resistance lingered. The idea of a cosmic beginning carried unsettling echoes of theology, of creation, of something beyond science. Many clung to the steady-state model, a universe eternal yet ever renewing itself. But in 1965, chance intervened. Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, stumbled upon a faint hiss that no adjustment could erase. It was everywhere, unrelenting, woven into the fabric of the sky. They had discovered the cosmic microwave background, the cooled afterglow of a fireball billions of years old. At last, the evidence could not be denied. The universe had exploded into being, a hot, dense singularity expanding into the cosmos we see today. The Big Bang became the great triumph of modern cosmology. Yet even as the celebration spread, a deeper question loomed. If this was the beginning of time and space, then what lay before it? Was there a before it all? In the glow of victory, science found itself staring once again into the abyss. The revelation that the universe had a beginning was not a quiet one. It thundered through science and philosophy alike, overturning centuries of belief. For as long as human thought had reached toward the heavens, it had assumed eternity. The stars seemed eternal. The heavens seemed immutable. Even Newton's clockwork cosmos, set into motion by gravity, ticked within an infinite framework of space and time that had no edge and no start. But the Big Bang spoke differently. It declared that time itself was not an endless river. It had a source, a spring where the flow began. This idea was not just new. It was revolutionary. To speak of a beginning of time was to tear apart the foundation of classical physics. Eternity had been the unshakable ground beneath science. Now that ground crumbled. If time had a first moment, then the question of what came before dissolved into paradox. The very word before lost meaning, for it implied a sequence when no sequence yet existed. To grasp such a thought was like reaching into darkness where even the concept of reaching did not yet apply. The shock of this realization rippled through the scientific world. Many resisted. The steady-state theory, advanced by Hermann Bondi, Thomas Gold, and Fred Hoyle, sought to preserve eternity. In their vision, the universe expanded, but new matter was continuously created to fill the gaps. No beginning, no end, just everlasting balance. It was a comforting thought, and for a time it stood as a worthy rival to the Big Bang. Hoyle himself, with a trace of irony, gave the rival its name during a radio broadcast, dismissing the concept of a sudden birth as absurd. Yet the term endured, outliving the resistance it was meant to mock. But evidence would not bend to comfort. The cosmic microwave background, the abundance of light elements, the large-scale structure of galaxies, all bore the fingerprints of a singular fiery origin. Still, the triumph of the Big Bang carried with it a haunting burden. For if time and space began, what then of the nothing that came before? Was it true nothingness, a void beyond imagination? Or was it something deeper, a hidden reality that science had not yet uncovered? Here the human mind falters. To accept that there was no time before time is to press thought against the limits of reason. It is to acknowledge a boundary where language collapses, where every word we know twists into contradiction, and yet we cannot let go. The question clings to us, pulling at our imagination with quiet force. If nothing existed, how did something rise from it? If something existed, what was it? A shadow realm of unknown physics? A seed universe? Or perhaps the endless silence that birthed all sound? This was the scientific shock of the century. Not merely that galaxies moved, not only that the cosmos had once been fire and flame, but that existence itself may have leapt out of an abyss that defies all comprehension. The Big Bang did more than describe the origin of stars. It forced humanity to face a truth it had never dared to imagine, that the universe was not eternal. That time itself is fragile, that the very ground of reality has a beginning, and perhaps one day an end. This is about 720 words. Would you like me to continue expanding it toward the full 1,800-2,000 word range with deeper detail on the steady state versus Big Bang debate, the philosophical shockwaves across different schools of thought, and the emotional tension scientists described in their writings? The universe carries memories written in light, faint, fragile echoes from its earliest moments, drifting across space for nearly 14 billion years. To study these whispers is to look back almost to the beginning itself, into an age when the cosmos was only a newborn, still glowing from its first eruption, and in that glow, hidden patterns seemed to carry the answers to a question humanity could not let go. What, if anything, came before? In the latter decades of the 20th century, cosmology changed its face. It was no longer a science of broad ideas alone. It became precise, almost surgical, armed with new instruments that could peel back the layers of cosmic history with mathematical accuracy. The era of precision cosmology had begun. The first great leap came in 1989, when NASA launched the Cosmic Background Explorer, known simply as COBE. Its task was to measure the faint microwave glow that Arno Penzias and Robert Wilson had stumbled upon decades earlier. What COBE revealed astonished scientists. The radiation filled the sky with almost perfect uniformity, as if every direction in space was the same. The pattern matched predictions of the Big Bang so exactly that it silenced nearly all remaining doubts. George Smoot, one of COBE's lead scientists, would later call the results like seeing the face of God. Yet in the same moment of triumph, a deeper riddle emerged. If the universe had burst from chaos, how had it grown so smooth, so finely balanced? The mystery deepened in the 1990s and 2000s, as successors to COBE sharpened the picture. The Wilkinson Microwave Anisotropy Probe, or WMAP, traced the faintest ripples in the radiation, tiny temperature differences of a millionth of a degree. These ripples were fossils of the universe's infancy, the seeds from which galaxies would eventually grow. Later, the Planck satellite refined these measurements still further, mapping the sky with exquisite detail. What emerged was a portrait of a universe that was not only expanding, but remarkably ordered. Its geometry appeared nearly flat, balanced on the razor's edge between eternal expansion and collapse. Its distribution of matter was strikingly uniform, with only the tiniest variations, and the numbers seemed tuned with uncanny precision. Why should the universe be this way? Why so smooth? Why so flat? Why so finely set? If the Big Bang had been even slightly different, galaxies might never have formed. Stars and planets might never have come to be. Life itself might have been impossible. The observations suggested not chaos but a strange elegance, as though the cosmos had been delicately prepared. This was not the randomness one might expect from a blind explosion. It hinted at something deeper. To answer these puzzles, physicists turned to the strange and uncharted world of quantum mechanics. In the early 1980s, Alan Guth, a young theoretical physicist, proposed an idea that would transform cosmology. He called it inflation. According to Guth's model, in the earliest fraction of a second, the universe underwent a staggering expansion, far faster than the speed of light. Space itself ballooned outward, stretching quantum fluctuations into vast structures. Inflation explained why the universe appeared so uniform, why its geometry was flat, why the seeds of galaxies looked the way they did. The idea was radical, but it fit the data with uncanny accuracy. Kobe, WMAP, and Planck all confirmed the predictions. The ripples in the microwave background matched the fingerprints of inflationary expansion. For the first time, cosmology linked the quantum realm where uncertainty rules with the vast sweep of galaxies. The very largest scales of existence bore the imprint of the smallest. The infinite sky carried the scars of quantum tremors. Yet even as inflation solved problems, it opened new abysses. If space could inflate once, could it inflate again? Could our universe be one bubble among many, each born from quantum fields expanding into infinity? This possibility gave rise to the multiverse hypothesis, where countless universes blossom like foam upon a cosmic sea. If so, then the conditions of our universe might be only one random draw from an endless lottery. Our smoothness, our balance, our very existence might not be inevitable, but a fragile accident among uncountable worlds. The philosophical weight of this idea was immense. For centuries, science had sought a single universe governed by universal laws. Now it whispered of infinite universes, each perhaps ruled by its own variations of physics. The meaning of before the Big Bang grew more tangled still. Perhaps there was no before, only other inflations, other bubbles stretching backward without end. Or perhaps the inflationary field itself existed timelessly, spawning universes without number. The data, however, told only part of the story. The background radiation, though uniform, carried subtle anomalies. Tiny cold spots, slight asymmetries, hints that the cosmos was not perfectly smooth after all. Some physicists wondered if these irregularities might be messages from a pre-Big Bang era, faint signatures etched into the fabric of light. Were they scars of collisions between universes where one bubble brushed against another? Or were they the echoes of deeper physics, quantum laws not yet written into human understanding? Each new measurement sharpened the mystery rather than dissolving it. The more precise the instruments became, the clearer the strangeness of the universe appeared. Flatness, uniformity, fine-tuning, and these were not random. They were questions disguised as answers. The human mind strains beneath such revelations. To think that space and time began is already to step into the unknown. To think further, that within the glow of ancient light lie patterns pointing to an even deeper origin, is to wander the threshold of comprehension. Perhaps the universe itself is a palimpsest, where one story is written over another, and faint traces of the erased script still remain. Some scientists suggest that what we call the Big Bang may not have been the ultimate beginning, but only a transition. A passage from one state of reality into another. Quantum gravity, still an unfinished theory, hints that space-time might not vanish at the singularity, but rebound, like a cosmic spring. If true, then our universe may have been born from the death of another, its ashes giving rise to our fire. Others imagine a timeless quantum state, a sea of potential where universes emerge as fluctuations. In this view, the question before loses meaning entirely, replaced by a landscape without beginning or end, where creation is not a singular event but a constant possibility. Still, even the most elegant theories remain unproven. Inflation itself, though supported by evidence, leaves many details unsettled. The nature of the field that drove it is unknown. The ultimate origin of that field remains unspoken. At every step, the chain of explanation pushes the question further back, never truly dissolving it. The satellites that mapped the microwave sky gave humanity the clearest portrait of the cosmos ever seen. They confirmed the Big Bang, revealed the fingerprints of inflation, and measured the shape of space itself. Yet they did not close the mystery. Instead, they framed it more sharply. They whispered that the universe is not only vast but profoundly strange, balanced on the knife edge of possibility. And so the investigation deepened, not into certainty, but into wonder. Every image from Kobe, WMAP, and Planck became more than data. They became mirrors, reflecting not only the birth of the cosmos but the limits of human thought. For in the ripples of ancient light lies a haunting reminder. The universe remembers more than we can yet explain. It carries within its patterns the suggestion of something beyond its birth, an unseen chapter of reality, waiting in silence. The deeper science looked, the more elusive the origin became. The Big Bang was no longer the final word but a doorway. Behind it lay questions of unfathomable depth, questions that drew us not away from science but closer to the core of existence itself. What preceded the first moment? What law, what field, what reality gave rise to the spark? In the precision of cosmology, in the glow of ancient photons, humanity glimpsed not only answers, but the contours of the greatest mystery. The birth of the universe is no longer only a story of beginnings. It is a story of horizons where each discovery pushes vision outward, toward the edge of knowledge where darkness still reigns. And beyond that darkness, the haunting thought persists. Perhaps the universe was never alone. Perhaps the silence before time was never empty. Perhaps the patterns in the sky are fragments of a truth so vast, our words can only trace its shadow. The investigation deepens, but the mystery endures. The universe was not content with simple expansion. It carried within itself a secret, a hidden pulse that would only be revealed billions of years after its birth. At the end of the 20th century, as astronomers traced the movement of galaxies, a revelation struck with the weight of a cosmic thunderclap. The expansion of the universe was not slowing under the pull of gravity. It was accelerating. In 1998, two independent teams, the Supernova Cosmology Project and the High-Z Supernova Search Team, looked deep into space and time. They observed dying stars, supernovae, exploding in distant galaxies. These stellar beacons served as cosmic mileposts, revealing the rate at which the universe had stretched across billions of years. The expectation was clear. Gravity should have been tugging at the fabric of space, slowing the great expansion like an anchor dragging on a rising balloon. Instead, the data showed the opposite. Space was racing apart faster and faster. Galaxies were being carried away on a tide that grew ever stronger. To explain this defiance of reason, cosmologists gave a name to the unknown force at work. They called it dark energy. Invisible, elusive, yet unimaginably powerful, it made up nearly 70% of the universe. It was not just a detail of the cosmos, it was the dominant reality. But what was it? A property of space itself, as Einstein's abandoned cosmological constant suggested, or some deeper field unknown to physics surging beneath reality? The discovery left more questions than answers, as if the universe had revealed its hand only to conceal a larger truth. The acceleration deepened the mystery of the beginning. If dark energy governs the fate of the universe today, might it also have shaped its earliest moments? Did it whisper at the edge of creation, influencing the balance of matter and radiation, steering the course of the infant cosmos? Each new observation tied the present to the past, suggesting that forces we barely understand had always been at play, hidden in the silence before time. As evidence mounted, the puzzles multiplied. The horizon problem, long a thorn in cosmology, demanded explanation. Why, if the universe expanded so quickly, did regions of the sky separated by billions of light years look so strikingly alike? The microwave background revealed a smoothness across the heavens that defied the limits of communication. Light had not had enough time to cross those distances, and yet the cosmos behaved as though it had been in perfect conversation with itself. Inflation offered an answer, but it was a theory on uncertain ground, leaving room for doubt and for speculation. Then came the flatness problem. Observations showed that the geometry of the universe was balanced on a knife's edge. Too much matter would have doomed the cosmos to collapse back upon itself. Too little, and it would have drifted into cold emptiness. Yet the density of the universe was tuned with extraordinary precision, balanced to within a fraction of a percent. It was as though the cosmos had been launched with impossible accuracy, its trajectory aimed toward survival. And behind all these riddles loomed the singularity. The point at which science faltered, the origin marked as time equals zero. In the mathematics of relativity, the singularity is where density rises to infinity, where the curvature of spacetime becomes immeasurable, where the equations lose meaning. Here physics does not whisper. It falls silent. To stand before the singularity is to stand before a wall. It is to reach the edge of reason, where knowledge turns to darkness. Beyond this threshold, science has no map. Was the singularity real? A physical state of infinite compression? Or was it only a flaw in our equations? A signal that the laws we know are incomplete? The question lingers, heavy with both promise and dread. For the human mind, the singularity carries a peculiar terror. It is not only the collapse of matter into a point, but the collapse of thought into paradox, a place where time begins but cannot be said to exist, a place where nothingness and being are one. It is here that science meets philosophy, and philosophy stares into the abyss. The singularity is not only a mathematical puzzle, it is a reminder of fragility. Everything we know, the galaxies, the stars, the ground beneath our feet, traces back to a moment that lies outside the reach of science. A moment where no experiment can probe, no telescope can see, no theory can fully explain. To ask what happened there is to confront the limits of human understanding. Yet in that silence, possibility thrives. Some theories suggest that the singularity was never truly infinite, that quantum gravity, the union of relativity and quantum mechanics, softens the edge, turning the singularity into a transition, a bounce where one universe collapses and another rises. If true, then our Big Bang was not the first, but only the latest in a cycle without end. Others propose that the singularity is a doorway, a boundary where our universe was born from a larger multiverse, a pocket of reality inflating into existence. In this view, the singularity is not the death of explanation, but its expansion, a sign that reality is deeper than our universe alone. Still others imagine that time itself may be emergent, not fundamental. That what we call the beginning was only the unfolding of order from a timeless state. If so, then asking what came before is like asking what lies north of the North Pole. The question dissolves, not because it is answered, but because it was never fully meaningful. Each possibility stretches the imagination, yet none brings closure. The singularity remains a riddle, a place where science touches the horizon of thought. Its silence echoes louder than any discovery, reminding us that knowledge has edges, and that beyond them lies mystery, the acceleration of the cosmos, the dominance of dark energy, the riddles of horizon and flatness, the enigma of the singularity, all converge into one profound realization. The deeper science peers into the birth of the universe, the more it discovers not simplicity, but strangeness. The universe is not only expanding, the mystery itself is expanding, racing ahead of our understanding, leaving us always at the edge, always grasping for a truth just beyond reach. And so the investigation becomes not only scientific, but philosophical. Does physics end at the singularity, its voice extinguished by paradox? Or does a deeper reality begin there, hidden from our view, waiting for the next revolution of thought? The answer may determine not only the fate of cosmology, but the fate of meaning itself. The silence at the beginning remains. A silence filled not with absence, but with questions. Questions that echo louder with every discovery. Questions that stretch as wide as the cosmos and as intimate as thought itself. In the face of dark energy and the shadow of the singularity, science finds itself humbled yet compelled to press onward. For beyond the silence lies the possibility of truth, and perhaps just beyond the wall of time lies the origin of all things. The deeper science gazed into the origin of the cosmos, the clearer it became that the Big Bang was not an ending point of inquiry, but a beginning. At the singularity, equations falter and silence reigns. Yet in that silence, imagination awakens. Theories rise like constellations in the dark, each one an attempt to pierce the veil of nothingness, each one daring to ask what came before the beginning. One of the most radical visions arises from the strange laws of the quantum world. Quantum mechanics insists that emptiness is never truly empty. Even in the void, particles flicker into existence, paired opposites emerging and vanishing in fleeting sparks of energy. Physicists call this the quantum vacuum, a restless stage where uncertainty is law. Could the universe itself have emerged from such a vacuum, a fluctuation vast enough to ignite space and time? According to this view, the cosmos may have sprung from a quantum nothing, a nothing filled with potential, governed not by absence, but by hidden rules. In this scenario, the Big Bang is less an explosion, more a transformation, where the seeds of existence blossomed from the tremors of uncertainty. From this idea grew the theory of inflationary multiverses. Alan Guth's inflation explained why our universe is flat and uniform. But it also carried within it a strange implication. Inflation once begun may never truly end. Pockets of space may stop inflating, becoming universes like ours while the greater fabric continues to expand eternally. In this picture, the Big Bang was not unique. It was one bubble in an endless sea of bubbles, each with its own laws of physics, its own galaxies, perhaps its own form of life. Our universe becomes one among countless others, a single ripple in an infinite foam. The philosophical consequences are staggering. If infinite universes exist, then every possibility may be realized somewhere. A universe where gravity is stronger, another where stars never formed, another where time flows differently. Our existence becomes less inevitable and more accidental, one outcome in an endless lottery of creation. Some find comfort in this cosmic abundance. Others find disquiet in the thought that the universe we call home may be no more privileged than a single grain of sand on an infinite beach. Beyond inflation lies string theory, a framework that imagines the fundamental particles of nature not as points, but as tiny vibrating strings. In this vision, additional dimensions curl invisibly around us, hidden in scales too small to see. From string theory emerges brain cosmology, the idea that our universe is a three-dimensional membrane floating in a higher dimensional space. If so, then what we call the Big Bang might have been the collision of two such brains, immense sheets of reality brushing against one another, unleashing energy and birthing a cosmos. In this picture, the void before our universe was not true nothingness, but a vast multi-dimensional arena, a stage where universes are born from cosmic collisions. Other thinkers return to the idea of cycles. Perhaps the universe is not a singular event, but an eternal rhythm. Expansion gives way to contraction. Galaxies collapse, stars die, and the cosmos itself falls inward, until all matter and energy converge. Then from the depths of compression, a new expansion ignites, a new universe is born. Such cyclic models suggest that our universe carries the ashes of previous ones, that the Big Bang was not creation ex nihilo, but renewal. Time in this vision has no beginning, no end, but a pulse infinite in its repetition. A darker speculation arises from the concept of false vacuum decay. In this scenario, the vacuum of our universe, the lowest energy state of its fields, may not be truly stable. It may only be a false vacuum, precarious, waiting to collapse. If so, then our cosmos emerged from a transition, a bubble of true vacuum forming within a higher energy field. The Big Bang would then be an act of escape, our universe breaking free into stability. Yet the possibility remains that one day even our current vacuum might decay, erasing everything in an instant. The same process that gave us birth could one day bring us to an end. Loop quantum cosmology offers yet another vision. By weaving the principles of quantum mechanics into the fabric of spacetime, it proposes that the singularity may not exist at all. Instead of infinite density, the universe may have reached a finite minimum size, then bounced outward. In this model, the Big Bang is not a beginning, but a rebound. Before our expansion, there was a contraction. Before this universe, another universe collapsing, then giving birth. In this view, the cosmos may stretch back through cycles without number, each one giving way to the next. Taken together, these theories expand the imagination to cosmic scale. They challenge the human mind to envision realities where time is endless, where universes are infinite, where nothingness itself is a fertile sea of hidden laws. They remind us that the word nothing may never mean what it seems. Even in absence, there may be structure. Even in silence, there may be music waiting to be heard. And still, the question remains unresolved. Did the universe spring from a quantum fluctuation? Was it born in a multiverse of infinite bubbles? Was it the child of colliding brains or the rebirth of a dying cosmos? Is the vacuum that holds our existence stable, or does it tremble on the edge of collapse? Each answer leads not to finality, but to further mystery. Each theory illuminates a fragment of the truth, yet leaves the horizon dark. The human struggle with these ideas is more than intellectual. It is emotional, philosophical. To consider that time had no beginning, that universes may be infinite, that what we call nothing is pregnant with possibility. This is to stretch the boundaries of thought to breaking. It is to peer into a reality that may never be fully grasped, yet still compels pursuit. Perhaps the greatest revelation of these speculations is not which one is correct, but that the universe demands such daring thought at all, that the cosmos is so mysterious it forces humanity to imagine beyond its limits, that silence itself is fertile, and that the absence of answers becomes the very ground for discovery. The Big Bang was once seen as a beginning. Now it appears as a doorway. Beyond it lies quantum foam, infinite bubbles, hidden dimensions, eternal cycles. Beyond it lies the haunting possibility that nothingness itself is an illusion, that before time, before space, before matter, there was not void but potential, a sea of hidden laws, a canvas upon which existence could be painted. Theories multiply, speculations diverge, yet all converge upon the same truth. The universe does not surrender its origin easily. It draws the human mind ever deeper into the paradox where science and philosophy meet. At the threshold of the beginning, one finds not only the riddle of existence but the reflection of humanity's own longing to understand. The question persists. Not merely what happened at the Big Bang, but what reality itself is made of. Whether the silence before time was truly empty, or whether it carried within it the first whispers of everything to come. And so the mystery deepens, not diminished by knowledge, but enriched by imagination. For in seeking the origin, science uncovers more than facts. It uncovers wonder. It reveals that to ask what came before is not to find an end, but to glimpse the endlessness of possibility. The search for the origin of everything is no longer carried out only in thought. It unfolds in vast machines buried underground, in telescopes gazing across cosmic distances, in detectors listening to the faintest tremors of spacetime. Humanity has begun to build tools powerful enough to brush against the edges of creation itself. Each instrument is both a question and a hope, a device designed to wrestle secrets from the silence of the beginning. Beneath, the countryside along the border of Switzerland and France, lies one of the most ambitious of these tools, the Large Hadron Collider at CERN, a circular tunnel stretching 27 kilometers buried deep underground, where protons are hurled to near-light speed before colliding in flashes of energy. Here, physicists attempt to recreate conditions that existed less than a trillionth of a second after the Big Bang, for in those collisions may lie the keys to understanding how the universe transitioned from nothingness into something. It was within this collider that the Higgs boson was discovered in 2012, a particle that confirmed the existence of the Higgs field, the invisible energy field that endows matter with mass. Without this field, no particle would cohere, no atom would form, no star would ignite. The discovery validated a central piece of the standard model of particle physics, yet it also opened new questions. Could the Higgs field itself be linked to the vacuum energy that drives cosmic acceleration? Could it help explain why the universe emerged in the first place? Some calculations suggest that our vacuum is not fully stable, that the Higgs field may be precariously balanced, teetering on the edge of decay. If so, then our cosmos lives on borrowed time, born from instability and destined to return to it. Colliders continue to probe deeper, searching for particles beyond the standard model, dark matter candidates, supersymmetric partners, hidden dimensions. Each failed detection refines the mystery, narrowing the paths that remain open. Each collision is an attempt to force the universe to reveal its blueprint, to show what laws governed the first instant when space and time awoke. Beyond the Earth, telescopes peer into the ancient light that still bathes the sky. The Planck satellite provided the sharpest map of the cosmic microwave background, revealing fluctuations in temperature so subtle they resemble brushstrokes on a cosmic canvas. These ripples are relics of the universe's first instance, fossil records of quantum tremors stretched by inflation. Yet even Planck's vision has limits. To push beyond, new eyes are being turned to the sky. The James Webb Space Telescope, stationed 1 million miles from Earth, gazes not only at galaxies, but at the faint red-shifted light from the earliest stars. While its mirrors are not tuned to microwave background, its observations of the first galaxies test models of how the infant universe evolved. The structures it sees, massive galaxies forming earlier than expected, challenge cosmologists to refine their understanding of what the universe was like in its first billion years. Upcoming missions like the Simons Observatory and CMBS-4 aimed to probe the polarization of the microwave background, searching for subtle patterns known as B modes. These patterns, if found, would be the smoking gun of inflation, a fingerprint left by gravitational waves from the first fraction of a second. Gravitational waves themselves are now part of the quest. Since 2015, detectors such as LIGO and Virgo have recorded the ripples of spacetime, caused by colliding black holes and neutron stars. But theorists dream of something even more profound: primordial gravitational waves. Unlike those from merging stars, these would be echoes from the very birth of the universe, vibrations in spacetime triggered by inflation itself. If detected, they would carry information from before the cosmic microwave background, further back than any light could reach. In those faint ripples would lie a direct message from the beginning, written in the fabric of spacetime itself. The search is not confined to observation alone. Quantum cosmology, an attempt to merge the principles of general relativity with quantum mechanics, is being tested against the precision of new data. Loop quantum cosmology predicts that the Big Bang may not have been a singularity, but a bounce where a prior universe collapsed before giving rise to ours. Other models suggest that quantum fluctuations created spacetime itself, that the laws of physics emerged as the universe cooled. High-precision observations of the microwave background, the distribution of galaxies and gravitational waves are being compared with these predictions. The data may reveal which visions are illusions and which hint at the true nature of the beginning. Into this effort enters a new ally: artificial intelligence. With simulations too complex for human calculation, AI is being trained to model entire universes. It can test billions of scenarios, varying laws and conditions to see which match the cosmos we inhabit. Some simulations attempt to reach before the bang, to explore whether the fingerprints of pre-Big Bang physics could be encoded in the patterns we see today. AI is not merely a tool of speed but of discovery, able to perceive correlations too subtle for human intuition. It is as though humanity has built a mirror of thought outside itself, a partner to extend vision into the darkness where imagination alone cannot reach. Yet for all this power, the silence remains. No collider has revealed the true nature of dark matter. No telescope has yet detected primordial B modes. No gravitational wave observatory has heard the echoes of inflation. Each tool brings progress but also humility, reminding us how elusive the origin remains. The effort to probe the beginning is more than technical. It is existential. To build a collider miles in circumference, to launch telescopes into space, to listen for tremors smaller than an atom in the Earth's crust, all of this is an expression of the same ancient drive. The drive to know where we came from and what came before. Humanity bends steel and light, gravity and computation, all in service of a question that may have no final answer. Perhaps the universe guards its birth too carefully. Perhaps the singularity will remain forever hidden behind a veil no instrument can pierce. Yet each attempt sharpens the picture even when it fails. Each unanswered question reframes the mystery, showing that the origin of the cosmos is not a single point of knowledge, but a horizon that recedes as we approach. And in this pursuit lies something profound. For to ask what came before the Big Bang is not only to investigate physics, it is to measure the reach of human spirit. It is to witness the paradox of a species that knows it is finite, yet longs to understand the infinite. Particle colliders strike sparks that echo conditions of creation. Telescopes map light older than stars. Detectors listen for vibrations older than galaxies. Simulations conjure possible worlds. All of it converges on one truth. Humanity is attempting to bring clarity to the unknowable, to shine light into the silence that lies before time. Perhaps the answers will come. Perhaps they will not. But the act of searching itself becomes part of the story. For in that search, the universe does not simply reveal its mysteries. It reveals us, our willingness to confront the abyss, our refusal to turn away from the dark, our insistence that even at the edge of knowledge, we will continue to look outward. The tools are built. The questions remain, and the silence of the beginning waits patient as humanity strains to hear its voice. The story of the cosmos has always been a story of longing. To ask how the universe began is to ask how existence itself found a voice. It is a question that rises from the depths of human need. The need for origins. The need to trace the threads of reality back to their first weave. For millennia, Civilizations told creation stories not because they knew, but because they could not live without asking. The search for the beginning is older than science, older than history. It is stitched into the human condition. And yet the closer science comes to the moment of birth, the more fragile the concept of a beginning appears. The paradox of nothing reveals itself. Perhaps nothing has never truly existed. Perhaps the void humanity imagines has always been an illusion. Physics suggests that even emptiness seethes with potential, with quantum fluctuations, with hidden rules that refuse to be silenced. In that view, the Big Bang was not the leap from nothing to something, but the unfolding of laws that had always been waiting. If so, then the very idea of nothingness dissolves, replaced by a fertile void, a sea of possibility beneath existence. But there is another possibility, that time itself is the illusion. To imagine a beginning is to imagine a before. Yet if time arose with the universe, then before has no meaning. The Big Bang may not have marked the start of something, but the start of time itself. Asking what came before may be like asking what lies north of the North Pole. An elegant question, but one without answer, because it presupposes a framework that does not exist. In this way, the birth of the universe confronts humanity with a profound challenge: to think beyond thought, to reason beyond reason, to accept that some questions dissolve even as they are asked. Einstein once said that the most beautiful experience we can have is the mysterious. For him, mystery was not ignorance but wonder, the recognition that reality is larger than comprehension. It was this humility before mystery that drove his search for truth, a search that reshaped the human view of space and time. Yet even Einstein's equations, so powerful and precise, fell silent at the singularity. His mathematics could describe the flow of the cosmos, but not its fountainhead. Stephen Hawking carried that silence further. In his no-boundary proposal, he suggested that the universe may have no edge, no starting point, no singularity where time begins. In his model, time curves back on itself like the surface of a sphere, finite yet without boundary. Just as there is no edge where the Earth ends, only a continuous curve, so too the universe may have no point where existence began. The question of before becomes meaningless, not because it is trivial, but because the universe may be self-contained, complete within itself. Such proposals do not end the mystery. They only reshape it. If the universe is boundaryless, what law made it so? If nothingness has never existed, then what deeper reality gives rise to the fertile void? Philosophy and science converge here, each pressing against the same horizon, each humbled by the darkness that lies beyond. For humanity, the emotional weight of this pursuit is immense. To stand at the edge of knowledge and look outward is to feel both awe and insignificance. The cosmos is vast beyond measure, and yet its birth may lie in laws so delicate they defy imagination. In seeking the first moment, humanity confronts not only the universe but itself, its need for meaning, its fear of silence, its refusal to accept ignorance as final. Perhaps the most haunting possibility is that the ultimate answer may never be known. That no collider, no telescope, no simulation will ever pierce the veil of the beginning. That the silence before time will remain silent forever. Yet even this is not defeat. For in the pursuit itself lies a kind of revelation. The act of asking, of building machines to chase whispers, of shaping theories to confront paradox, is itself a mirror of the human spirit. It shows that humanity is not defined by answers but by the willingness to seek them. The closing images of this story are not final truths, but lingering questions. Perhaps before the Big Bang there was not nothing, but something our minds cannot yet conceive. Perhaps reality is layered, infinite, unfolding in ways forever beyond language. Perhaps the greatest illusion is that the beginning was ever a single moment, rather than an eternal process, without origin and without end. To imagine such things is to stand on the threshold of comprehension, to feel the thin line where knowledge meets wonder. The pursuit of origins does not erase mystery. It deepens it. It shows that the universe is not a solved equation, but a poem still being written, a song still being sung. And in that song, humanity hears its place. Fragile, finite, yet capable of wonder. Capable of looking into the darkness and refusing to look away. Capable of shaping meaning even when the cosmos offers none. The universe may never give us the answer we seek, yet in the search, we find something just as profound. We find the measure of our own longing. Perhaps in the end, this is the deepest truth, that the universe is not only stranger than we imagine, but stranger than we can imagine, that its beginning may never be captured in words or equations, only in awe, That before the Big Bang lies not emptiness but mystery, waiting forever just beyond reach, and in the silence before time, the cosmos still whispers.